Hi, in this video I'm going to explain about the 7 theorems that we had learned in our class. So the first theorem is Rolle's theorem. So for these theorems, it states that if a function is continuous on the closed interval AB and differentiable on the open interval AB such that function of A is equal to function of B, then the differentiate of function of x is equal to 0 for some x with x is less than b and greater than a. So now we have a graph, and this is continuous curve. Okay, so if a continuous curve passes through the same y value twice and has a unique tangent line derivative at every point of the interval, then somewhere between the endpoints it has a tangent parallel to the x-axis. The second theorem is mean value theorem. So this theorem is typically an abbreviated mean value theorem. It describes a relationship between average rate of change and instantaneous rate of change. Geometrically, this theorem describes a relationship between the slope of a second line and the slope of the tangent line. So we have a graph here. Suppose we are looking for at a function on an interval AB. The line connecting the endpoints, which is the second line, will be parallel to at least one of the function's tangent lines. In order for this to be true, the function has to be continuous and differentiable on the interval. So we can see somewhere in interval AB, there is tangent line that is parallel to the second line. For the third theorem is intermediate value theorem. This theorem, the idea behind the idea behind this theorem is when we have 2 points connected by a continuous curves, which is they have 1 point below the line and 1 point above the line, then there will be at least one place where the curves crosses the line, which is here. The curve must be continuous. In other words, when the curve is the function, which is y equal to function which is continuous on the interval AB, and w is a number between function of a and function of b, then there must be at least one value of c here within interval AB such that function of c, which is w, the function y at the same point must be w equal to fc. As it also says at least one value of c, which means we could have more c. For here, this is an example, we have more than one c. So if you want to know how this intermediate value theorem is useful, whenever we can show that there is a point above some line and a point below that line and that the curve is continuous, so then we can safely say yes, there is a value somewhere in between that is on the line. So for the fourth theorem, which is Cauchy mean value theorem, this theorem is generalization of the usual mean value theorem. So it established the relationship between the derivative of two function and changes in this function on a finite interval. It states a function of f and g are continuous on the closed interval of a and b and differentiable on open interval a and b. Then there exists some C between the open interval a and b. Okay, so such that f function of b minus function of a we times with the differentiate of gc equal to gb minus ga times with f of c. This is, and of course, the differentiate of gc is not equal to 0 for all x in interval ab, and the ga is not equal to gb. So this is equivalent to f prime c over g prime c equal to f function of b minus function of a divided by function gb minus ga. Geometrically, this means that there is some tangent to the graph of the curve which is parallel to the line defined by the points FAGA and FBGB. So let's move to the fifth theorem. Okay, the fifth theorem is Taylor's theorem. Okay, Taylor's theorem state that if the function of f and its first n plus 1 derivative are continuous on an interval containing a and x, then the value of the function at x is given by this formula, where Rn of x is defined as remainder. So remainder can define as function by n plus 1 times with c divided by n plus 1 factorial times with x minus a by n plus 1. So the sixth theorem is Maclaurin's theorem. It's basically a Taylor series become a Maclaurin series if the Taylor series is centered at the point of 0. It is the expansion of the Taylor series of a function about 0. So it is a special case in which a is 0. So basically it's just same with Taylor's theorem, but it just centered at the point of 0. And lastly is second mean value theorem. So basically it is also just like Taylor's theorem, but when n is 1, so we have this formula for some c between a and x. So this often called the second mean value theorem. So that's all. Thank you.